All right. Let's talk about dilation. So dilation, you're probably most familiar with, as it has to do with people increasing the size of their pupils, as we see in this picture. Now, when an object is dilated, like the pupil here, it doesn't change location. The only thing a dilation does is around the center of dilation, the size changes. So maybe the size changes from large to small, or maybe it goes from small to large. Dilation works both ways in math. Let's look at an example. Let's say we have the quadrilateral GHIJ, and it's dilated to form the quadrilateral G prime, H prime, I prime, J prime. So we started here at this little triangle, and we got, that's not a triangle, that's a trapezoid, I apologize. We started with a little trapezoid, we ended up with a big trapezoid. Now we want to find which of the following statements is false. Now first it says the ratio of GH to G prime H prime is equivalent to the ratio of H prime I prime. Now that is a true statement, but let's go ahead and confirm. So G to H, well that's 1, 2, 3. G prime to H prime, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then we're going from I to H. Well, if I use Pythagorean theorem to solve for that, then I know a squared plus b squared equals c squared. So we have 3 squared plus 1 squared equals c squared. 3 squared is 9, plus 1 is 10, so the square root of 10 is equal to c. And then if we did the same thing to solve for h prime I prime's length, see this is 3 long and this is 2, 4, 6, 8, 9, this is 9 long. Then we'd have 9 squared plus 3 squared equals c squared. We're still using Pythagorean theorem. That gives me 81 plus 9 equals c squared, which is 90 equals c squared, which means the square root of 90 equals c. Ooh, I need to figure out if this is a true statement. In order to figure out if this is a true statement, I'm going to rationalize my denominator here. Rationalize my denominator. So I know 90 is equal to 10 times 9, and 9 is equal to 3 times 3, which means I have a number pair here. So I can rewrite my right side fraction as the square root of 10 times 3, since a pair comes out and the 10 is stuck inside. Which if I simplified that, the square roots of 10 would cancel out and I'd have 1/3. Now, simplifying the left-hand side is going to be much easier. Let's see. I could say that that's 3 times 1 over 3 times 3, because 3 times 1 is 3 and 3 times 3 is 9. 3's cancel and we have 1/3. So both ratios are equal to 1/3, so we know that that this first statement is true, so it's not our answer. But remember that whenever we have a dilation, we have similar figures, and therefore the ratio of their sides is equal. Now this one, it says side GH is congruent to side G prime H prime. Now that we know is false because we've already proven that GH is 3 long and G prime H prime is 9 long. And is 3 congruent to 9? No, it is not. That's our false guy. Okay, the two figures are similar. We already mentioned that whenever we have a dilation, we have similar figures. All corresponding sides are proportional. That is a definition we get from similar figures. Any questions on that? Let's keep going. We're given this triangle WXY. Triangle WXY is dilated to form triangle W prime, X prime, Y prime. The lengths of the sides of W prime, X prime measures 15 units. Okay. Let's see, from W to X originally, it was 1, 2, 3 units. So 3 multiplied by what gave me that 15? We know that's 5, so we have dilated by a factor of 5, which of the following is true. The angle W prime measures 9 degrees because the scale factor of dilation is 1/5. Okay, we already said the scale factor of dilation is 5. The other thing you need to consider whenever you're dealing with a dilation, while all of your side legs change, none of your angle measures do. So we know this one's false, as our angle measures never change with dilation. The side WX is congruent to W prime X prime. No, it's 5 times greater. The angle W measures 45 degrees, the angle W prime measures 45 degrees because the corresponding angles of WXY and W prime X prime Y prime are congruent. That is a true statement. Whenever we make something bigger, the angles don't change. We'd be probably dealing with some triangle that looks something like this, if we're being perfectly honest, where we still have a right angle, it's still 45 degrees. And the measure of angle W measures 50 degrees because we add 5 to both the lengths of the sides and the measure of the angle. No, that is completely false. You never add when you're dilating. If you add, you're translating. Dilating is multiplication. Figure ABD is similar to EFH. Which of the following describes the transformations of ABD to EFH? Okay, now we're going from ABD to EFH. So A will correspond to E. B will correspond to F. And D will correspond to H. Okay. So if we're looking at that, it does get slightly bigger. So we know we're dealing with a dilation. Let's figure out which one we did. The figure was rotated 180 degrees and then dilated by a factor of 2. Okay, if I look at this, there was no rotation. A and D correspond to E and H, which stayed on top the whole time, so we know that's not our guy. The figure was dilated by a scale factor of 2 and rotated 90 degrees. Again, if it was rotated, then E and H wouldn't be on top. The figure was rotated 90 degrees. Okay, we know it's not rotation. Aha! That means we know it's this guy. Let's go ahead and do the work and make sure that it's that guy. So it says the figure was shifted vertically 3 units. Okay, so if it went 3 units, then XY would become x, y plus 3. And then it's dilated by a factor of 2, which means then we would multiply by 2. Let's go ahead and do one or two of these points, just double check. It looks like B is at the point -3, -2. Let's start with that -3, -2. Well, when we add 3 to our y value, we're going to end up with -3, 1. And then we're going to multiply by 2, and that's going to give us -6, 2. Now, if we look at f, where is it? Oh, it's at -6, 2. That's fantastic. So we know that this figure was indeed vertically shifted up 3 units and dilated by a scale factor of 2. Remember, whenever you have a scale factor, all you're going to end up doing is taking your points and multiplying by that scale factor. The figure ACD is similar to the figure EGH. Which of the following describes the transformation from ACD to EJH? Okay, again, let's match up our pieces. A corresponds to E. Okay. C corresponds to G. Okay. And D corresponds to H. Now, the first thing I notice here is it looks like we have a reflection going on. So I'm going to just underline whichever one talks about reflection. And I know anything that doesn't talk about reflection is wrong. And now if we look at these two, has it been reflected over the x-axis or the y-axis? Well, this right here is the x-axis. So we only have one problem that actually talks about that. It says figure is dilated by a scale factor of 2 and reflected over the x-axis. Let's go ahead and double check the math on one point, and then we know that's the answer. So we would take our xy. Now, first step it says was dilated by a scale factor of 2. So that means we're going to multiply by 2. And then it was reflected over x. So that means we're going to make, apologies, make our y value the opposite. Let's see. What do you say we just pick point C? Point C sounds fine. Actually, no, I don't want to pick point C. The reason I want to pick point C is it's 1, 1. And so if x and y change positions, I wouldn't know it. But if I pick point D is a great point because it's 1, 3. And so if x and y ever change, I'll know about it. Okay, so we start with 1, 3. Let's multiply by 2. We'll have 2, 6. And then we will reflect over the y-axis. So we'll have 2, -6. Okay, if I go to 2, -6, that is where h shows up, which is exactly what I wanted. I wanted D, subtract h. Perfect. Figure ABD is similar to figure EFH. Which of the following describes the transformation from ABD to EFH? Okay, A corresponds to E. B corresponds to F. And D corresponds to H. Okay, was there any rotation or flipping happening? Nope. No, it wasn't rotated. It's still the same orientation, so we know it wasn't reflected. So we know it's probably the second choice. Let's go ahead and just do an example of how we would double check ourselves. So it says the figure was dilated by a factor of 1/3. So that means we would take our xy, we would multiply that xy by 1/3, and then shift it vertically 2. let's pick a point. Point B seems fine. That's at 6, -3. 6, -3. If we multiply that by 1/3, we'll get 2, -1. And if we add 2 to that, we'll get 2, +1. Well, what's at 2, +1? F. So indeed, this is our rule. This is our answer. Figure ABD is similar to figure EFH. Which of the following describes the transformations from ABD to EFH? Okay. So we went from A to E. Wait, this is the same problem again. I apologize. All right, circle 1 was dilated with the origin as the center of dilation to create circle 2. Which rule best represents the dilation applied to circle 1 to create circle 2? Okay, did it get bigger or smaller? Get from the little circle to the big circle, it got bigger. And it was dilated. Remember, dilation means we're multiplying by something. So we're not subtracting and we're not adding. Okay, now we need to look at these two options we have left. If we multiply by 1/3, would we get bigger? Probably not. If we multiply by 3, would we get bigger? Yeah, that's probably our answer. Let's go ahead and double check it. Let's pick a point. I'll pick this point and this point. They both seem fine. All right, so this point is 1, 0. Now, if I multiplied 1, 0 by 3, I would get 3, 0, which is where our second point is. So we know this is our guy. All right, a pentagon is graphed on a coordinate grid and then dilated by a factor of 1/2, with the origin as the center of dilation. If the vertex of the original pentagon was located at -4, 6, which ordered pair represents the vertex of the new pentagon after the dilation? Okay, so we'll take our 1/2, because that's our factor, and we're going to multiply it by a point. 4, 6, -2, 3. There's our answer. And that's all we have for dilation. Have a great day.